Page 32. Okay. So as I said, we're doing the exact same thing. We're finding percentages, but now we're going to use our calculator, not the graph. Saves us a ton of time, okay? So, use these when the values do not appear on the graph, okay? Use these two. These two are going to be your help when that occurs. No graph required. That's the beauty of this. No graph required. So we're going to use Normalcdf and inverse norm. To access either one of these, grab your calculators. I'm going to show you where to get that before I start talking about what it does or what they do. Okay? So you got to press second. You know what? I would honestly put this on my study sheet, how to access these two. Second, and then vars. I don't know if you see vars right here. It's right here under the arrows. Okay? Second, vars. And then you have Normalcdf and inverse norm. Okay? So I would tell myself, how do you get Normalcdf? I'll tell myself how to press it, because on the exam or whatever you might forget. So that's where I get this from, okay? And think about it this way. When you press second and vars, you're really accessing distribution. See that blue there? It says distribution, so we're talking normal distribution. So that's where you're going to find these two functions, okay? What does Normalcdf, what does that one do? What does it need? It needs a lower limit, an upper limit. So you need to tell it, find me the percentage between here and here, okay? Followed by mean and standard deviation. It needs 4 entries, always. It needs 4 entries. If you don't give it 4 entries, it's not going to do it for you. Okay. What does it do? It calculates the probability between the two values. However, the answer is given as a decimal. We multiply by 100 to get the percentage, so you need to make sure you understand that. Again, Normalcdf needs 4 entries, separated by commas. The lower limit is a value that would be to the left side of the curve, would be to the left side of the curve somewhere. Upper limit, obviously, it's somewhere to the right of the curve. And just a reminder, a different color for this one. If the z-score is given, if I give you the z-score, I don't need to give you the mean and the standard deviation. Because we know, you should immediately know that the mean is 0 and the standard deviation is 1. Remember, every time we put the 0 under the average, and then we go up by 1, right? So that's something that you need to know right off the bat. It's like, wait a minute, I need my mean and standard deviation. No, you don't. If I give you z-scores, you already know this. So technically, watch this. This would be 0, and this would be 1 when you enter the 4 entries automatically. Okay? So let's try this. I've given you graphs so you can wrap your head around it, but I'm not expecting you to do this. Okay? Example. Assume that the mean income for a household in a city is $45,000. Okay, so the mean here is $45,000. And the standard deviation is $15,000. Knowing that, and obviously we're assuming a normal distribution, what percentage of households earn between $32,000 and $65,000? Now, before we use the function, watch this. This is the average right here. I put that at the center. We know that it goes there. And then technically, I went up by 15,000 every time. That repeated itself. So I filled in this graph you would go minus 15,000, right? That's a standard deviation every time you go to the left until you get to 0. So that's how I came up with this. This is always in the back of our heads. We know that this is true. But if I don't ask you to graph it, why would you? Okay. In fact, are these numbers, look up here real quick, are these two values anywhere at the bottom of this curve of my graph? These two values, can you find them anywhere? No, but they're approximately where? 42,000 somewhere in there. Sorry, 32, my bad. 32 is there, and 65,000 is somewhere in there, correct? We want to know, let's use our, I'm going to use a red pen here. 32,000 is somewhere between here, and 65,000 is somewhere in here. So my goal, your goal, is to find out what percentage under this curve is found in here. Okay? And I will do this one more time. I'll ask you to put the 32,000, just make it go right there, and then it shoots all the way down to the x-axis. And the 65,000 is your upper limit right there. So we are now going to we're going to find out exactly what percentage of families earn between those two incomes. Does that make sense? Okay. We used to guess. By the way, when you were doing what you were doing yesterday, you were estimating. This is going to be exact. Okay? So here we go. Normal CDF. So you actually, I expect you to write this down on your paper, on your AC quiz, what have you. So you go 32,000. That's the low limit. 65,000 is the high. And what's my mean and standard deviation? I already know that. That's 45,000 and 15,000. And I just made my life harder here by putting these arrows in, so I'm just going to move the arrow. It's all good. It's all good. Okay. Got it? So let's press that. What are we going to get there? Oh, this is lower. This is upper. This is the mean. And that's a standard deviation. So you've got the 4 entries. So grab your calculator. These are the easier cases where you have the upper and the lower. Sometimes it will not give you the lower or the upper, and I'll show you how to deal with that. Second, VARs. Normal CDF, not PDF. Okay, we don't want PDF. It's going to give you something different. So you just select that and you go 32,000, comma, 65,000, comma, 45,000, 15,000. Close brackets. Hit equals. And there it is. So write that down. I'm going to write down just about, right? If you use all of them, that is as a decimal. So we multiply that by 100 to get our percentage. And it's 71.57% of households. Earn between 32K and 65K, just to make it short and sweet, right? So that's my final answer. That's how I come up with it. And you can kind of verify this, folks. It's not quite all of the 34, correct? It's not quite, but it's 34 plus a big chunk of this part and about half of this, right? But just remember, this chunk is bigger than this chunk because look at the curve, right? It's coming down. So you can't just like guess by yourself. You have to use the calculator for that, okay? Let's keep going. What about this one? What percentage? So when you see the percentage, you know it's going to be inverse norm. if you're using your calculator, that is. What percentage of households earn more than 75,000? Whoa, there's no upper or lower, is there? So you kind of have to understand that more than 75,000, 75,000 happens to be right here. Okay, so I want everything that is more than that income, all the households that make more than that. So by definition, I will want to figure out all of these here, the percentages that follow that tail going upwards. Okay, so this is how you go about it. Normal CDF. This is a low limit, folks. This is a low limit. So I want 75,000. And if I had an infinity button, I would press it right about now. But this calculator doesn't have an infinity button. Okay? So you just put in a really big number. So if it's 75,000, you could put down 1,000,000 or something. As many zeros as you feel like it. Okay? I'm going to put 1,000,000 down. Choose a big number. That's it. Okay, choose a big number. And the standard, the mean is still 45,000, and the standard deviation is still 15,000. Okay. So I'm just going to copy paste, okay, folks? Because it's I already have it there. I'm just going to bring it down. That might actually complicate things. It's not that much work. So you go 75,000, comma, 1,000,000, 6 zeros, right? 45,000 and 15,000. Close it, and there you have it. So that would give me 0.0227 and something, and multiply that by 100. That's 2.28% of households. So not a whole lot of households, right, make more than 75K in this scenario. A very small percentage. Hold on. If I always, some students put like 10 million in there. Can we just try that? I want to see how big of a difference that makes. I will not deduct when that happens. But just pick a big enough number, okay? Yeah, it's the same. I put in 10 million, and I still got 2.28. Okay. So again, this is estimating. The graph is estimating. This is exact. Okay. Let's keep going. What percentage of households earn less than 39,000? So you find 39,000. Whereabouts would that be? About right here. So you can make a dashed line. Okay. So you want all the households percentage-wise that are less than. Okay. You want all the households that are less than that, earning less than 39,000. So there's no lower given here. So normal CDF, what would you put down as your lower? Because this is the upper. You can go 0, you can even go negatives. Whatever you feel like it. So I'm going to go negative 1,000,000. And this is 39,000. Then it's 45,000, 15,000. Negative 1,000,000, that's silly, isn't it? Yeah, just go extremely as far left as possible to include everything that's possibly there. If there's something there, it's going to pick it up. So grab your calculators. I'm going to go second vars CDF. and I'm going to go -1 followed by 6 zeros, comma 39,000, comma 45,000, comma 15,000. And that is 0.3445 and then some. (34.46%) of households. So if 39,000 would represent a low-income family, then there's quite a few, like there's about a third of the households making, like kind of being in the low-income bracket, okay, in this case. So that's how normal CDF works. I will highlight what percentage again. What percentage? Okay, I'm just showing you how normal CDF works, okay? If I were to listen carefully to this part, what if I said this city had, 600,000 households? You could actually then take the percentage. I would actually take my decimal and multiply it by 600,000, right? To know the actual number of households we're talking about. So just so you know, this can be expanded. I just want to show you how normal CDF works. So nothing changes from what we've done before in terms of finding the percentages. It's just that we're using calculators to do that. Come with me real quick to 33. I want to show you the other function. It's called inverse norm. Inverse norm. This is on page 33. Okay, so what I need you to remember here, inverse norm, watch, how many entries does it need? It only needs 3 entries. It needs 3 entries, okay? What does it do? It will calculate the actual value along the x-axis, okay? So it could be the actual height, the actual weight, right, the number of days, anything like that, but it will calculate the actual value along the x-axis. What does it need? The biggest difference between the other one and this one is, first of all, that it's 3 entries. It's still mean and standard deviation at the end. That doesn't change. This is important though, this one right here. You need the percentage of data below the value you're interested in as a decimal. As a decimal. If you don't do that as a decimal, sorry, you can see that, it's going to be wrong. Okay, so if it's 70%, you need to put down 0.7. Just remember that. So, question here. Let's wrap our heads around this part. If the question says 35% of people earn more than $50,000 per year, right? That obviously means that the 35% is to the right of that value because you earn more. If this is 35, what would this section be here to the left? The people earning less. 100 minus 35. So this chunk automatically is 65%. So this is what inverse norm is interested in, the left side. And you can easily find it if you just do some math. Like if it gives you everything above it, just subtract it from 100 to get your lower percentage below this value. Okay? What if the question said if 42% of students spend less than 15 minutes on homework? Then what would you do there? 42% spend less. So you are given, listen carefully, it is giving you the left side, percentage-wise. Where would you put the 15 here? Where the middle would be 50-50, right? If it's 42, I need to move a little bit over to the left, wouldn't you say? To put the 15? and you can close this like that. And this is just to give you an idea, okay? This is not exact, okay? The 42% would actually go in here. That's exactly what you want. So sometimes students don't know how to visualize it, and it might take you a little bit. Oof, the 42 is kind of butchered there. Sorry, guys. I'm going to go arrow and just say 42% goes there. If this is 42, what's this? 58, right? But I don't care about it, because if you have the left, you've got everything you need to proceed with inverse norm. Okay. So let's try this. This income, so question mark. I don't know what this income is. It's going to be in dollars, right? I know that. Would have 30% of households earning less. It would have 30% of households earning less. So I'm interested in that income, somewhere along here. Where would you place it? I would encourage you to say, well, this is, if I found this value, it would be 50 and 50, correct? If 30% of households earn less, where would you go? This way or that way? This way, right? Because if you put this line, if you make this line here, it would make sense that this is 30 and this is 70. Right? Is the question giving me the below part? Yes. And look what I have. So if you think of less, shorter, right, earns less, right? Or then you kind of are thinking you're going to the left. If it says earn more or takes longer, it's kind of indicating you that they're giving you the percentage to the right. Okay, so let's do this one here. Inverse norm. You need to feed it the 30%. So you're going to go 0.30. What's the mean? I'm assuming we're still going by previous page, okay, guys? What was the mean on the previous page? 45,000, and the standard deviation was 15,000. So this is the mean, this is the standard deviation, and this is percentage to the left. So let's go try it. You got to press second bars. Okay, 0.3, comma, 45,000, comma, 15,000. Close it. And what is my answer going to be in? It's going to be whatever's along the x-axis, which is income. Okay? So this is not finding the percentage. This is actually giving you the value that you're looking for. So if you earned $37,133.99, right? That would mean that 30% of the families earn less than this. So this is what you're after. So it's totally different than normal CDF. Okay? Doesn't ask for a percentage in this case. It's asking you for the whatever the X value is. Let's do one more. At least one more, and then I want you to practice this going home, and then come back tomorrow with questions if you have them. An income of question mark would place a household in the top 20%. In the top 20% of household incomes. When you think top, you're thinking left or right of the curve? Right. So this is the top 20 right here. I don't care about that one, right? I care about this section. What is this then? 80. So I want this value, right, which is going to tell me that people that earn less than this, right, 80% of households earn less, 20 more. But just write this down. Inverse norm. This is 0.8. My mean is 45,000. My standard deviation is 15,000. This one I can probably copy paste on my calculator. Yeah, for sure. Because I can just go back and just change the 0.3 to 0.8. And then hit enter. And this would be 57,624. So an income of this would have, right, if you make this one or more, you're in the top 20. If you earn this or less, you're in the bottom 80. Think of it that way. I'm going to ask you to try pages 34 to 36. Make sure you practice. And one hint here, one heads up. I do ask you to graph. I do ask you to graph just like before a bell curve. But what does it say here? Use what? Use technology to answer this following. That means normal CDF inverse norm. Okay? Thank you guys. To be continued.